Well, hello there. Welcome to another video by Unnati Academy. In this one, we're going to touch upon how to find out derivatives of trigonometric functions. For example, sine x, cosine x, and tan x from basic principles, right? So we know the derivative of sine x is cosine x. That's right. The derivative of cosine x happens to be minus sine x. And the derivative of tan x is secant squared x. Right? So let's see how to get these results. All right. So we get started with sine x, which is our first function here. Let's call it y. Y equals sine x. Now, if I go a little bit further on the x-axis by an amount delta x, I go on the y-axis an extra amount delta y, right? So if I need to just find out this guy, delta y here, I subtract these two equations from each other. This is called equation 2, equation 1, and I do 2 minus 1. So I get delta y equals sine of x plus delta x minus sine x upon, well, all right. Now, we're going to come closer to finding the derivative by dividing both sides of the equation with delta x, and then I'm going to say limit delta x tending to 0 on both the sides, and this is what we define as dy by dx, or the slope of the function at a given point x, right? Now we can apply the sine A minus sine B formula here, and that is equal to 2 cosine A plus B by 2 sine A minus B by 2. So let's apply it here. 2 cos A plus B by 2, which is x plus delta x plus x upon 2. So that'll be 2x plus delta x upon 2 times sine A minus B by 2. So that's going to give us just delta x upon 2 and divided by a delta x here, and the limit still stays. Right? Now let's move to the next step here. So let me make some space here. Now I'm going to take this 2 down, and this is going to get converted into limit delta x tending to 0 sine delta x upon 2 upon delta x upon 2. This is one limit, and we know this to be equal to 1. And multiplied by the other limit, which is limit delta x tending to 0 cosine of, now I'm going to change this to x plus delta x upon 2, right? And the next step, I'm going to put in all these values here. So this limit goes to 1 times, now when delta x goes to 0 here, all I'm left with is a cosine of x, right? So that is the way to prove that dy by dx equals cosine x when y is sine x. So that is the first one proven. Now let's move on to the second one. The second one is cosine x. Applying the same principles that we applied to sine x, we're going to start with writing y equals cosine of x and y plus delta y equals cosine of x plus delta x. And subtracting these two, we get delta y equals cosine of x plus delta x minus cosine of x. And divide both the sides by delta x, we get this. Limit delta x tending to 0, applying this on both the sides. This is the definition of dy by dx. Now we're going to apply the cosine A minus cosine B formula here. And this is equal to, what is the cosine A minus cosine B formula? It's minus 2 sine A plus B upon 2 sine A minus B upon 2. Right? Now we apply this here. So this becomes minus 2 sine 2x plus delta x upon 2 times sine of delta x upon 2 over delta x, limit delta x tending to 0. Now I can take this 2 down here again. So this becomes, let's go here, delta x tending to 0 minus sine x plus delta x upon 2 times the other limit, delta x tending to 0 sine delta x upon 2 upon delta x upon 2, and this limit goes to 1 as we know, and hence we are left with just minus sine x times 1 or minus sine x. So that way we prove that the derivative of cosine x is minus sine x. So now we're done with the first two. Now let's move on to the third one, which is tan x. Well, this promises to be a bit more interesting, right? And let me erase the board and start here. Delta y equals, replace this by tan of x plus delta x minus tan of x. And delta y by delta x is just this. Limit delta x tending to 0 on both the sides. That's the definition of the derivative. Right, so what is the next step here? Now we have tan A minus tan B. Now I can choose to write this as sine A upon cos A. And that's how I can perhaps simplify it a bit more. So limit delta x tending to 0 sine x plus delta x upon cosine x plus delta x minus sine x upon cosine x, and the whole thing divided by delta x. Now cross multiplying, we'll get limit delta x tending to 0 sine x plus delta x times cosine x minus cosine x plus delta x into sine x, and the whole thing divided by cosine x plus delta x times cosine x times delta x. Now let's see what this looks like. This looks like sine A cos B minus cos A sine B, which is nothing but sine A minus B. So this is going to give us sine of x plus delta x minus x upon delta x times cosine del x plus delta x times cosine x. And the last step, now this is essentially equal to, let me make some space here. Limit delta x tending to 0 sine delta x upon delta x, and we know this limit is essentially 1 times 1 upon cosine x into cosine x plus delta x. Now, as delta x goes to 0, this limit goes to 1. So 1, and this expression goes to 1 upon cosine x times cosine x. And this whole thing is nothing but secant square x. And that's how we prove that tan x differentiated gives you secant square x. Well, that is the end of this video. And see you soon in the next one. Thank you so much. Bye.